Hello, everyone. Hope everyone is doing well today. Today, we are going to continue working on quadratic functions in the work that you got yesterday. You were asked to do questions 1 through 21, and I had worked through some with you. Hopefully that went well. If not, I would suggest you rewatch the video again and try to follow along and fill in the information and try the first 21 problems first before you continue with this video. We are going to work on another application very similar to the things we did yesterday. It's just that in the real world, and when you throw a ball up and it lands, it doesn't land at exactly 10 seconds. It's usually a decimal or fraction. Same with the height. It doesn't usually go up to 50 exactly feet. It's 50.1 or 50.16. So today we're going to work on a problem that doesn't have nice numbers when we calculate the information. So if you scroll all the way down to the end of your packet, or I guess this is not a paper packet like it would be if we were in school, but we are going to work through questions 33 through 38 together. So either just watch and listen and fill it in later, or follow along now. So the question says, a ball is thrown into the air from a height of 7 feet at a speed of 54 feet per second. The path of the ball can be modeled by f of x equals negative 16x squared plus 52x plus 7. So it gives you the story, and then it gives you the important equation. That's what we're going to use to find how high the ball is, how long is it in the air, what's its maximum height, all those kinds of things. So it just in general, what's happening is you're throwing a ball, it goes up and it comes back down. So one other interesting piece in this problem right here, it says that it's thrown from a height of 7 feet right here. So that means its starting height right here is 7 feet. It's not at 0, 0 going up and down. Okay, it's actually starting at 7 feet. So that's kind of some information we want to kind of be aware of. And just note, but again, that's our y-intercept. So that's 7 feet right here. This 7 feet right here, that's our y-intercept. So let's take a look at the questions. I'm going to read through them, and we don't always have to answer them in order. Answer them whichever one you think is going to be the easiest for you to answer, do that one first. It says, how long will it take the ball to land after it's been thrown in the air? Well, that's this point right here. We want to know how long it's going to take to land. And when it lands, its height is equal to 0. So what we're really going to find out is we're going to find out when the equation, when the time, the x value, is equal to 0. So we would be setting this equation equal to 0. That's what we'll do to find how long it's in the air. So that's that part right there. That's really our x-intercepts, okay? That's where our parabola would be crossing, or in this case, hitting the x-axis. So I'm not going to start the graph yet because I'm going to need to know what kind of numbers I have to graph in order to label the scale. The next question says, how long does it take for the ball to reach its maximum height? So now we're looking at this point right here. How long is it going to take us to get to that maximum height? And what is the greatest height? Well, these two questions right here, this is your vertex. So when we calculate that vertex up here, that's going to give us how long and how high, that maximum point, that vertex. The question 36 asks how long, after 1 second, how high is the ball? And then it asks us to graph in another additional question after we've graphed it. So we're going to go through and solve some of these. Now, I think a lot of times the vertex is easier for a lot of you to calculate. So I'm trying to find that vertex. Well, this equation is in standard form. So to calculate the vertex, okay, the x value of the vertex is negative b over 2a. Write that a little bit neater, negative b over 2a. That's going to give me my x value of the vertex. So That's how long. So what I'm going to do is I'm going to take my equation, and I'm really finding the axis symmetry, but I'm going to have x equals the opposite of b. B is 54, so negative 54 over 2 times my a, which is negative 16. Again, use your calculator here. But your x value, if you take negative 54 and you divide it by negative 32, what you get is 1.6875 seconds, or we'll round for simplicity of graphing, 1.7 seconds. So that's how long it takes to reach that maximum height. Now, what is the greatest maximum height? Well, that's our y value of our vertex. That's the maximum height. How we get that is we plug the x value into the equation. So I am going to really find f of 1.7. So I'm going to take and plug in 1.7 seconds for the time, and I'm going to find the height at that. So negative 16 times 1.7 squared plus 54 times 1.7 plus 7. So my height, again, use your calculator, enter that into your calculator with the parentheses, and you'll get 52.56, or again, we'll round to 52.7. So try to write this a little bit neater for you. So what I've found out so far is I found that how long it takes the ball to reach its maximum height is 1.7 seconds. I found out that the greatest height the ball reaches is 52.7 seconds. Like that. So maybe I can clean this up a little bit. So 52.7 seconds. So those are going to be pieces of information. That's going to be my vertex up here. So let's go ahead and start labeling our graph, and let's maybe even put our vertex on there. Well, we know this bottom value, our x is our time, okay? And we know our y values are our height. So I know my time has to go 1.7 seconds. I don't know what the maximum time is, but I kind of do, because the halfway point is 1.7. So if I double the halfway point, that gives me an estimate of how long it's going to be in the air. So I've got a lot of space down here. What I'm going to do is I'm not going to go 1 second for each line. I'm going to go a half a second. So it's going to be a little bit easier to graph. So this would be 1 second at that line, 2, 3, 4, 5, etc. Okay, so now for the height, I need to go at least to that maximum height of 52.7. So I need to go up, my graph needs, these lines need to go up to more than 50. Well, I can't use a space of 1 or 2, that's not going to be enough. So what I'm going to have to do is space this, every line could be 5. So here's your 0, and then here's 10. And then here's 15, and here's 20. And then here's 30. And 40, and 50, 60. Okay, I have at least enough space for that now. All right, so let's go ahead and graph that vertex. So 1.7, well, here's 1.5 right here, okay? And 1.75 would be exactly in between 1.5 and 2. So I'm going to kind of estimate right here, in between there as best I can. There's my axis of symmetry, and my vertex is 1.7. It's on that line, and then 52.7. Well, here's 50, here's 55. So 52.7 is almost right in between those two values. So my graph is kind of small, but there is my vertex right here. And sometimes it's helpful to actually label that vertex. So that is the ordered pair 1.7, 52.7. So I've answered the first two I've answered 2 of the questions. How long it takes to get to that maximum height. This is the time, 1.7 seconds, and how high is the maximum height, 52.7. So let's figure out how, after 1 second, how high the ball is. We know at 1.7 seconds it's at its maximum height, but what about at 1 second? So let's go ahead And let's find the height when our x value is 1. So I'm going to put a 1 now in for the time. And when I, again, plug all that into my calculator, I actually get 45 feet. So this answer is 45 feet. So at 1 second, that's this mark right here, I'm at 45 feet. So that's exactly halfway between 40 and 50. So there's that point right there. Now, I can go ahead and reflect that point over because of the axis symmetry, so I've got a good idea kind of how my graph is starting to look. But what I don't know is exactly what time it's going to take until the ball is on the ground. So now I'm going to go back up to this first question that we kind of skipped because it is kind of hard. We've got to solve that. And we set the equation equal to 0, so we have to find the values of x that make it equal to 0. Well, when we do that, what we have to use is factoring, greatest common factor, or multiply and add up, product sum, or we need to use the asterisk method, or we need to use the box method. We need to have a method to do that. Well, I don't really have a greatest common factor here because, some numbers go into 2 out of the 3, but nothing goes into 7 except 1 and 7. But what I can do is I can factor out a -1. Whenever the leading coefficient is a negative, we're going to take out that negative to make our life a lot easier. So now when I take out a -1, I get 16x squared, I get -54x, and I get -7. So now, I still don't have any other GCF, and since the A value is not equal to 1, I can't use multiply and add up. So now I'm going to use the asterisk method. So you could use the box method. Okay, the asterisk method asks me to find A times C. So when I put in A times C, that is going to be 16 times -7. Which gives me -112. Okay, now my bottom value is just my B, so that's -54. So now my A value goes on the top of the line, which is 16. And now I need to use product sum. So now I do use multiply and add up, and I try to think of two numbers that multiply to -112 that add up to -54. Well, I don't know what to try, but I'm going to try 2 first because I know 2 goes into each of those. So if I take 2, okay, and I take 112 and divide it by 2, I get 56. Well, it has to be -112, so one of those numbers has to be negative. Well, if I make the 56 negative, now I have 2 times -56 is your -112, and 2 plus -56 is your -54. So I found my numbers. Wow, that was lucky, I guess. So it doesn't matter where I put these, but I'm going to put the 2 over here and the -56 over here. Now I need to reduce those fractions. So I take a look at 16 over 2, and that reduces to 8 over 1. And I look at 16 over -56. Well, 8 goes into 16, 8 goes into 56. So if I divide each side by 8, I get 2 over -7. Now I take those fractions and I plop them in as factors. I'm kind of running out of space here, so I'm going to draw an arrow. Hopefully. Draw an arrow and continue my work down here. Well, that's not going to be real great when I go through my graph like that, so I'm going to continue this down here. So what I do is in the first parenthesis, I'm going to put 8x plus 1. And the second parenthesis, I'm going to put 2x minus 7. And that equals 0. So using the zero product property, what that means is that 8x plus 1 has to equal 0, or 2x minus 7 equals 0. So in this first example, I'd subtract 1, which would give me a -1, and x then would equal -1/8. In the second example, if I add 7 and divide by 2, my x value here is 7 over 2, which is 3.5. So that means down here, this 3.5 is one of my x-intercept, and the other one is -1/8. Well, The reason it's negative 1/8, it's like way over here, just a little bit past 0. But the reason is because remember that y-intercept. Our starting height for this ball was not at 0, it was at 7. So it was about right here. So now, okay, I have the information I need. Okay, I have that it is, I already graphed it actually because that was going to be part of what I did. So 3.5 seconds and negative 1.8. So I have all the pieces graphed. Now all I have to do is actually draw the graph. So this is this question right here. Use the information to make the graph. So I could start back here if I want, but that's the important piece right there. So not too bad, just got to keep working through some decimals sometimes and fractions and do your best to graph them as accurate as possible. The last question I'm asked to answer over here says, can the ball pass over a tree that is 40 feet tall? Well, here's where 40 feet is. Can my ball pass over that? Yes, because it goes up to what was it, 52.7 feet. This should actually be feet here. There. All right, so I did the hardest one with you. Go back, finish trying these problems to the best of your ability. Check the answer key. I'll post the rest of the answers today. And then please take advantage of emailing me questions or messaging me questions so that I can try to help you. Have a great